Let's do this. All right. Log equals a log equals a log equals a log. Blah, 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 blah. All right. We got to solve for x. So what do we do? People? Hello? Huh? What? Any ideas? What? Okay. Any correct ideas? Nobody has an idea. What do you mean? Yes! Philip! Combine the logs, right? And we're adding, which means you are multiplying the arguments. Now what? Did you say do it? What do we do now, peoples? The bases are the same on the logs, right? So that means if the logs are the same, base 10, then I just have to make the arguments the same. So it's just like when we did this type of question. When you get the bases here the same, you just remove them and equate the exponents. Except here, once we got the logs the same, we just remove them and equate the arguments. So therefore, 2x has to equal x minus 3, x minus 2. And then it's just a grade 11 algebra problem, right?
What the hell just happened? Hold on, say that again. Sorry. Oh wait, the arguments have to equal each other? Is that what you just said? Okay.
So then we just algebra it. Hopefully this factors. It does. Fudge. Did people get to this point?
Okay, yeah.
I'm getting scared now.
Okay, that's not the answer.
Oh, it's 7x.
What?
Well, what are you waiting for?
I'm waiting for people to catch up. Okay, are we done? Why are we not done? Okay, so does 6 work? 6 works. Does 1 work? No, because if you go 1 minus 3, you get a negative number, and it all blows up. So x equals 6. I don't even know what to say to that. Are we good? Does everybody understand that? Put it in the original. What's 1 minus 3? Negative 2. Can't log a negative. So it all blows up. So always check it in the original. Okay. So we've done logs equal a number. So when logs equal a number, you put the logs together, you change to exponential form. That's this thing. If it's all logs equaling logs, put them all together, then drop the logs and equate the exponents. The only other one we haven't done is, what have we not done? I'm just going to make it up off the top of my head. What do you think the odds of this working out are? That was way too fast.
Can we do a simplifying one?
Yep.
Yeah, all of it. Not the minus.
Remember these?
Oh yeah.
Remember these ones, peoples? This is for you, Emma. All right. So, when you have one of the logs in brackets, all squared, can you drop that 2 down? No, you cannot, because it's not on the argument. But what you can do, and what you want to do, is you want to make this and this the exact same, because we're going to use Emma's trick of doing a substitution. But right now they're not the same. So how do I make this the middle term equal or the same as the first term? Drop the 7. So I can rewrite it as log base 3 of x all squared minus 7 log base 3 of x equals negative 6. Now, this is gross, so we need to get rid of the logs. What are we going to do? We're going to do substitution. So we're just going to say a, or whatever variable you choose, is going to be your logs. A squared minus 7a equals negative 6. What type of equation is this? Quadratic. It's the same as the one above. That's why I know it works. That's what I stole it from. So what does A equal? Are we done? That's it? We're good? Go home? Yes. Why are we not done? Because we're not solving for A. What are we solving for? Solving for X. So you put the 1 and the 6 into this equation. So you get 6 is equal to log 3 of X, or 1 is equal to log 3 of X. How do you solve those? Change the exponential. I don't know what 3 to 6 is. I don't really care. Those are your answers. What do you have to do? Check them. Do they work? They both work in the original. Okay. Is that okay? So we're all comfortable with logs?
Oh yeah.
Oh, you want a big expression that you simplify down? Yeah, it'll be a multiple choice. All right, I'm just going to make this up. Can you simplify that? No. Hmm?
You can get it pretty simple.
All right. Can 8 be made into base 2? What's the second thing? That's just 5, right? Because the bases match. If you log the number 1, it's 0. And this one can be made into so the first one is just 3 plus 5 minus 0 plus 2 is equal to Are we okay with that? Okay. All right, peoples, you ready for trig? What time does this class end? 20 after? We're going to do that on Monday because it's shorter. And I feel like trig, more people are going to struggle with that. And it's a bigger part of the test. 08? 20. 20 to 11? Oh, 11, 20. Okay.
Not 22. 22.
Yeah,
How long have you been working there?
Don't make fun of me. You're not even in this class.
Whoa, I wasn't.
You're a guest.
I am a guest.
And you're being quite rude.
Sorry.
And this is all being recorded, so it's all in the video.
Oh, is it really?
Yeah.
Nice. Have this documented. My mom does not believe me when I tell her the things I do in this class, so I show her how.
You don't do anything in the class. Like bad things? You don't do bad things.
She just thinks I'm a quiet person who sits in the corner.
Oh. Well, I'll send her an email today.
Okay.
Trig! Everybody's favorite.
Do not draw.
Okay. You should know how to convert between degrees and rads. Just because I don't think I asked, maybe I asked one question on that, but it's kind of just built into bigger questions. So how do you go from degrees to rads? What do you multiply by? Well, it's got to be, it's not a whatever question. There's a right answer. Wow. I apologize for anybody on YouTube watching this video. So times pi over 180 to go to rads. If you're going the other way, you multiply by 180 over pi. Yes?
Yes.
Okay, sure. Okay, then we did A is equal to R theta. That's for these sort of sector circle thingy-majiggies. There's your R. This is your arc length. Theta. Theta's in the middle. What's the only thing when you use this formula? What does theta have to be in? Rads. You need to know the trig graphs because they will not be provided for you. SOHCAHTOA? I guess. How do you find theta? Divide A over R. Okay, show me the question later. All right. Okay, you need to know the trig graphs. So, boom. What did you think I meant when I said trig graphs?
Don't eat donuts. Stop asking. I thought you had about the right angle triangle.
Okay, which is which?
Sine, cosine.
Yeah.
Are you gonna leave those up for final?
What? They're on your formula sheet.
Oh, okay.
I can write that on the board if you want, but. All right. Sine cos tan. Do I need to put the numbers in? All right.
It's like that is close to the sine. This is why the sine points are those on the center of the curve.
There you go. 1, -1, 1. There's your graphs. You need to know those. Okay? Mostly sine and cosine. I don't think I asked you anything about the tan graph, but yeah. Why not?
Is it gonna be one where you have like
Please don't.
Please don't.
Please don't.
I can't remember.
You should check. Let me know.
I'll get back to you next Thursday.
Wednesday. Said Wednesday.
Okay. How do you find the period of? I guess we have these two are the same. So, period of a sine or cosine graph is what over what?
something of the 2 pi.
Period for a tan graph is pi over b or 180. I mean, you can do it either way, right? Okay.
Can I write those on the formula sheet? Or should I know this?
You should know this.
Okay.
You've never seen that before. You so have. Like I don't. All right. A sine b x minus c plus d. This is the transformation equation just put into a trig function, right? And then they changed the h and k to c and d for whatever reason. How do you find the a value? And what does the a value represent on a sine? It could be a cosine graph as well. It's the amplitude. So a is the amplitude. How do you find it given a graph?
Divided by 2.
It's teamwork. Good job. Max minus min over 2. B value we've already talked about. Period is 2 pi over b. D value. Yeah. So that it'll give you the midline of the graph, and it's max plus min over 2. And remember the C value is kind of weird. There's 2 ways to find it. For a cosine graph, what do you look for? The peak. So the C value for a cosine graph, I'll look for the peak. For a sine graph, you are rising midline. Can you do A and D for a tan graph? From a tan graph? You can't do it if I give you the graph. I can say you do a vertical stretch by whatever factor, and that'll be the A value, and you shift it up 10 units. That would be the D value, but you cannot calculate it from the graph because there's no max or min. Okay? Are we okay so far? I'm putting... I'm here to entertain you. Is that my job? Okay. Are we okay? Okay, no. Okay. Okay. All right. Okay. It's a lot of okays. All right. Sine of x is equal to sine squared of x is equal to no, let's just do sine of x. Is equal to a half, negative a half. Solve for x between 0 and 360. What do you do? Find the reference angle. How do you find the reference angle? Push some buttons. There you go. Inverse sine, or the arc sine for those of you. Sine to the minus 1. You'd never use the negative, right? What does the negative tell you? Which quadrant you're in. So sine is negative in the 3, 4. Add sugar to coffee or insert your own words into that. You could also use the graph, just as a side note. Sine is negative in quadrants 3 and 4. All right. What was the reference angle? 30. So we know that is 30. We know this is 30. So what does x equal? 210 and 330. If for whatever reason I said do it between 0 and 2 pi, your answer has to be in rads. What's 210 in rads? Okay, the reference angle is 30. What's 30 degrees in rads? Pi over 6 is 30 degrees. How many 30-degree angles are there in 210? 7, so it's just 7 pi over 6. How many 30-degree angles are there in 330? There's 11. Okay? Is this starting to flow back into your brain? Okay. That's kind of trig 1. It's kind of boring. Trig 2 is where the fun stuff happened. All right, we ready for trig 2? No, you have the same fun I do. All right. Trig 2. What? Oh, you want to do those? Okay. Let me do a trig 2 equation first. So let's solve. So trig 2, they made a sequel. All right, this is trig 2. Trig number 2. Boom. 6 sine squared x minus 5 sine squared x equals negative 1. You just wrote this test like before Christmas. No. Did I say it was squared? No. Well, it's not. What type of equation is this? It's quadratic. How do you solve quadratics? Algebra. You get everything to one side and you factor, right? So you got to pull the 1 over. Plus 1 is equal to 0. And then you got to factor it. Pick your method. I don't care how you do it. I do decomp. First and the last is 6. Well, multiplies to 6 and adds to negative 5. Negative 6 and 1. Does this work? Doesn't work, does it?
It's 3 and 2, isn't it? Negative 3 and negative 2.
Yeah. I know how to factor. Yeah. I don't know what I was thinking. There we go. Okay. That's right, correct? Did I do it right this time? 3 sine x minus 1, 2 sine x minus 1? So then you just set each bracket equal to 0. And then you solve them. We just did the half. The reference angle is 30. So x on this side is 30 and 150. On the other side, I don't know what the reference angle of a third is. 19.47. That's gross. Let's just round it to 20. I'm rounding to 20 degrees for the simplicity. So it's 20 and 160. So those are all your answers, right? Between 0 and 360. What if I ask for the general solution? So this would be all the answers between 0 and 360. If I say the general, what are you going to do?
Multiply them all by n times the period.
There you go. So you just take them all and just go 30, 20, 150, 160 plus n 2 times the period, which is 360. That makes sense for general? Yeah? Questions?
Do I have to write n is every real?
No. Technically you should. I don't care. Just
Do
it's being recorded now. So I am telling them they don't have to do it for my test. But if you're in university, you are responsible for defining that n value. Covered.
You got-
All right. Are we good?
Why is there 2?
Where?
The n to 360. Why do we put it like that?
There is no 2. I'm on fire today.
There was though, right?
No?
I did have
I'll be better in the afternoon. This is the warm up.
Is that always how this goes? You're just warming up so you can.
Because I'm so good in your class. All right. What if you have a number? Let me. What if you have a number beside the x inside the trig function? Let me finish. Oh. Okay, what do we do? That's probably going to make it more complicated. What? You could. Double angle, you could probably do that, but I don't want to do it this way. What do we do?
We have no idea.
Well, neither do I. Solve it as regular. So where is cosine negative? Two and 3. So we know we're in those quadrants. Find your reference angle. $60 degrees. So you're here, you're there, right? So at this point, if it was just x, we would go x is equal to 120 and 240, right? But it's not x. What is it? So there's a 2 there. I don't want 2x, I want x. So what do? Divide them off. So x is equal to 60 and 120. How many answers should we have? should have 4, right? Because remember, it's 2 times whatever that b value, or yeah, I guess the b value is. So we know we need 4. So how do I get the rest of the answers? Add what? Sorry? You add the period. So plus the period. What's the period of cos 2x? It's 180, right? Because period of a cosine graph is 360 over b, which is 360 over 2, which is 180. So you add 180 to 60, and you get 240. And then you add it to 120, and you get 300. What happens if you add 180 to 240 again? You're over the domain restriction, which I didn't write, but would be from 0 to 360. Okay? Does that make sense? You remember doing those? You're the only one, apparently. Okay. Yes? What?
Yeah, you really need to.
Is it good now?
Yeah.
Checking my work. Okay. Proof? Should we do a proof?
Yes.
No? There's a proof on the test. All right, last question for today. Prove. What do you think the odds of me getting this right are? Probably not high.
I have faith in you, Mr. Rollins.
That's quite the mistake. Based on the performance I'm giving today, that is not
I think you're doing swimmingly.
swimmingly.
Yeah.
Watch you just make one that's not for
Yeah,
now.
that would not be a good.
We can't leave this room until we get out of here.
All right, remember, you get your formula sheet.
I just need the formula.
You want me to just leave you to do it right now, and then go over it, or you want me to go over it with you? Okay, we'll pause the video so that we don't have a recording of the nightmare that is this. Okay, what do you do? Start on the right side. Change everything to sine and cos. So boom, that's what I did there. Ignore the white stuff. I just changed the tan to sine over cos. The sine stay the sine. This tan was sine over cos. Sine. Then I looked at it and I said, 2 fractions, make a common denominator. So I multiplied cos and cos. Yeah? Okay. So then you get this. Because sine times sine is sine squared over cos. Sine minus sine cos over cos. Is that good? Yeah? What happens to these cosines? They're going to cancel. If you flip the denominator, they're going to cancel. So the cosines are going to go away. And you can factor a sine out. So I can factor a sine out of here. That's how I got this. This cos and this cos are going to cancel. So I have sine times 1 minus cos over sine squared. Which does that? No? Yes? We're good? That's kind of trig 2. I'll start Monday's class with a proof. Trig 2 is like identities and solving those quadratic equation things. So I'll start Monday's class with one of those and a proof, and then we'll do rationals, and then we're basically done. Tuesday will be just bring all your questions to me and fire them away and tell me what you want me to go over. Wednesday is a Copernican day, so we don't have class. So that's Wednesday is A, C, and then Thursday is B, D. So you write on Thursday. Next Thursday is your final exam. Okay? Yes.
This Friday, the weekend.